So let's look at part B. Well, I'm not going to apply all tests in part B, but I'll try to pick the best test applicable for the given series. So why don't you stare at part B and see what we can apply for. Okay, so you have 2n over 3n minus 2. Okay, so this looks to me like it's divergent, because right off I can apply the end-term test, right? Because the limit of the general term doesn't look like to be 0, right? So again, you can pause the video, think about it. Okay, think about it. So here we go. Where is the series here? So let me just grab that here. And here we go. Okay, so let's look at the limit of the nth term, right, which is an. Okay, this is infinity over infinity type indeterminate form. Well, you know the L'Hopital's rule, right? Take the derivative of the top, take the derivative of the bottom. Limit of this is equal to, just this is a constant term, so limit is 2 over 3, which is non-zero. Okay, that's awesome. So nth term test implies that this is divergent. Okay, because the limit of the general term is not equal to 0. Okay, so this was quick because if you think that the limit is not equal to 0 for the given series, then why don't you apply the nth term test? And that's an immediate conclusion. Would you be able to apply other tests? Sure. There are some of them which you can't apply for sure, like p-series test, for example. You can't apply this. Why? Because this is not a p-series, right? Geometric series test. Well, you can't apply that because this is not a geometric series. Neither telescoping series, right? So you can't apply those, obviously. But you can check the integral test if you want to. If you think that you can integrate 2x over 3x minus 2, go ahead and then just do the integration. The integral shouldn't be that hard. Limit comparison test and direct comparison test could be applicable as well. So you can actually compare this series to just 2 over 3. Okay, which is a constant series. Constant series means what? This is the summation of 2 over 3, 2 over 3, all the way to infinity. So infinitely many 2 over 3's takes you to infinity. Okay, so that means that either in the limit comparison test or in the direct comparison test, you should get in the direction of divergency. So this series is divergent.